All right, let's just dive right into this. Welcome to this explainer where we are going to completely unpack the vital, high-stakes, and honestly, fascinating world of system administration. Today, we're doing a whiteboard-style breakdown so we can really visualize what goes on behind the blinking lights of a data center. You know, we interact with technology literally every single second of our day, but we rarely stop to think about the invisible scaffolding that keeps the whole digital world from just collapsing. Well, that scaffolding is managed by a very specific type of IT professional. So grab your virtual markers and let's map out the true hero's journey of IT.
Okay, picture this. It's 2 a.m. The office is pitch black. Out of nowhere, the company's main server crashes hard. The database drops offline, the main website is throwing a giant 500 error, and the CEO is currently sweating in their pajamas, staring at a completely blank screen. It is a dramatic, incredibly high-pressure scenario, but trust me, it's a very real Tuesday in enterprise IT. When everything breaks, there is only one person who gets that dreaded late-night phone call, only one person who can step in, read through pages of cryptic error logs, and actually save the day. That person is our hero for today, the sysadmin.
So what is a sysadmin, really? Well, you can think of them as the ultimate doctor of computers. Just like a doctor monitors your vital signs to keep you healthy, a sysadmin ensures an organization's digital heartbeat stays alive and kicking. They are entirely responsible for the uptime, the performance, and the security of these massive multi-user systems. Without this critical infrastructure in place, nobody's sending an email, nobody's saving a file, and the whole company pretty much grinds to a halt before the workday even starts. They are the background tech generalists who make sure everything is always humming along perfectly.
Section 1. Linux versus Windows Server. When you step into the enterprise world, you're generally going to see two massive titans ruling the server room, and there is a huge philosophical difference between them. On the left side of our whiteboard, we have Linux. The absolute golden rule of Linux is that everything is a file. Your configs, your hardware devices, your network sockets, they're all just text files, and you manage them through the command line using tools like bash. Now on the right side, we have Windows Server. This environment leans heavily on a graphical user interface, the registry, and an object-oriented shell called PowerShell. Just to put this divide into perspective with a real-world example, if you want to simply list the files in a folder, a Linux admin quickly types ls, while a Windows admin types dir. Two totally different languages achieving the exact same thing.
And this breakdown brilliantly illustrates the strategic foundations of both platforms. Looking at identity, Windows Server is famous for Active Directory. It is basically the gold standard for centralized user management in the corporate world. Linux, meanwhile, generally uses LDAP or tools like free IPA. For scripting and automation, Windows admins love PowerShell because it handles complex data objects natively, while Linux admins will string together powerful text-based commands using Bash or Python. And down at the literal bedrock, the file system, Windows relies on NTFS or ReFS, whereas Linux uses incredibly robust systems like ext4 or XFS, which have advanced features to stop data corruption if the system suddenly loses power.
Moving right along to Section 2, Identity and Access Management.
Think of this as the digital equivalent of handing a brand new employee their office keycard on day one. Let me draw this out for you. Managing users isn't just creating a simple login. It's about strictly defining exactly which doors that keycard can unlock. Take a look at the SMIT interface. This is a graphical tool used in IBM's AIX system. Interfaces like this let administrators easily manage users, assign groups, and control what we call sudo privileges. Now, sudo is essentially a temporary VIP pass that lets a regular user run a command with absolute god-tier administrative power. You only hand that out when it's absolutely necessary. So the big takeaway here is how these systems distribute those keycards. Windows streamlines it beautifully with Active Directory and group policies. You can instantly grant or revoke a user's access across thousands of machines with a few clicks. Linux, on the other hand, is much more granular. It relies heavily on precise file-level controls. You'll use commands like user_add to create an account, passwd to set the password, and then commands like chom and shawn to literally lock down individual files and folders. That way, people can only ever access exactly what they need to do their jobs and nothing else.
Section 3. Storage and File Systems. Let's wipe the whiteboard clean for a second and look at where all this critical data actually lives. Underneath those file systems like ext4 and NTFS, we have the physical hard drives. And here's the harsh truth: hard drives fail. It's just a fact of life. That is why sysadmins use RAID, which stands for Redundant Array of Inexpensive Disks. To visualize this, think of RAID 1 as making an exact photocopy of every single document the very second it is saved. You have two disks, and the exact same data is written to both simultaneously. If one disk literally catches on fire, the system doesn't even blink. It just keeps running from the other one. RAID 0 gives you raw speed but zero safety, while RAID 5 blends speed with safety by spreading a mathematical safety net called parity across multiple drives. Section 4. Networks and core services. You know, a server sitting all by itself in a room is really just a very loud, very expensive heater. It needs a network. Watch what happens when we finally connect these isolated servers to the rest of the world. There are two core services you absolutely must know: DNS and DHCP. You can think of DNS perfectly as the ultimate phone book of the internet. Computers only talk in numbers, which are IP addresses. But humans, we can't remember random strings of numbers. We remember names, like google.com. DNS is what translates the name into the number. Working right alongside it is DHCP. Imagine walking into a massive conference. DHCP is the person at the front desk handing you a name tag and assigning you a seat number, so you can actually communicate with everyone else in the room.
Once your network is flowing, you have to manage the actual processes running on the machine. This right here is your daily toolkit. Systemctl starts and stops your background services. Top gives you a live rolling dashboard of what's eating up your computer's brain power. If a program freezes up and refuses to close, you use the kill command to forcefully terminate it. And specifically, kill 9 when you really mean business. Oh, and here's a fun one, the cron command. Cron jobs are exactly like setting a morning alarm for your server to run automated tasks, except the server never ever hits snooze. And to manage all this at a massive scale, sysadmins use scripting, writing simple bash loops or using tools like Ansible to fire off these commands across hundreds of servers all at once. As a sysadmin, you are also the chief security guard. But remember this phrase: security is not a product you buy, it is a habit you practice. You have to actively harden your systems. This means aggressively configuring firewalls, using tools like IP tables to block unwanted traffic. It means using SSH keys for secure, encrypted remote logins instead of relying on weak passwords, and enforcing the principle of least privilege, which we talked about earlier. Furthermore, using monitoring dashboards like Prometheus and Grafana, or even just checking htop, is basically hooking your server up to a heartbeat monitor. It lets you spot weird anomalies and digital sickness long before the server actually flatlines. Which brings us to the ultimate safety net: disaster recovery. There is an old, slightly painful joke in the IT world. There are two types of sysadmins: those who back up and those who haven't lost data yet. It is never a question of if hardware will fail, but when. Relying on rigorous backups, utilizing synchronization tools like rsync, taking system snapshots, and religiously following the 3-2-1 backup rule. That means keeping 3 copies of your data on 2 different media types with one stored completely offsite. That is literally the only way to ensure your company survives a catastrophic event. And finally, Section 5, the career roadmap. So where does a modern sysadmin go from here? Because the days of just managing physical metal boxes in a freezing cold server room are rapidly evolving. Today, the game is all about virtualization and the cloud. Picture containers like Docker as perfectly packed little lunchboxes. Everything a specific application needs to run, the code, the tools, the libraries, is packed neatly inside that one isolated lunchbox, making it incredibly easy to move around from server to server. And the cloud, platforms like AWS or Azure, well, the cloud is really just a fancy way of saying your company's data center moved into someone else's much larger, much better managed building. But make no mistake, someone still has to administer those systems. If you want to chart your course in this field, certifications are a fantastic way to validate your skills. Starting with fundamental certs gives you that solid networking baseline. Then, moving into something like the CompTIA Linux Plus heavily prepares you for the actual realities of modern enterprise environments, focusing a ton on automation, scripting, and security. As your skills evolve, you can tackle vendor-specific heavyweight certifications like Red Hat's RHCSA or Cloud Architect certs from AWS and Microsoft Azure. Those are the milestones that will transform you from a junior troubleshooter into a senior automation and infrastructure architect. We've covered the operating systems, the file structures, the network connections, the security habits, and the career path. Armed with this roadmap, the only question left for you is, when are you going to take the first step toward mastering the systems that literally power our modern world? Whether it's spinning up a tiny virtual machine on your laptop today, or just typing your very first command in the terminal, the entire journey starts with a single keystroke. Thanks so much for joining me on this explainer. Keep learning, and I'll catch you in the next one.